Hello everyone. So today the topic we're going to study is carbanion. Now let us start by seeing what is a carbanion. For example, if I take CH4, which is methane, and I draw it by exposing all the CH bonds that we have. So we have 4 CH bonds, and thus what I'm going to do is I'm going to write them 4 sigma bonds we have, and thus this is the methane that we wanted to draw. Now what happens is I break this CH bond, and what I do is I release an H positive from this. Now if an H positive is released, this is H positive which is just released by us. Now what we are left, the carbon is left with a negative charge on it, because as a bond breaks, it gets divided into a positive and a negative charge simultaneously. So we are left with a negative sign on CH3. So we get CH3 with a negative sign, and this is known as carbanion. So this is what we wanted all along. So any carbon with a negative charge, anion. Anion is a negative ion. So carbanion is a negative charged carbon. So what we have done here is, when I was removing this H positive from, when I was removing this H positive, while I was removing it, this H positive actually was, if I write, it was the most acidic hydrogen. Now, what we need to remember is that this H positive is an acidic hydrogen. So we removed an acidic hydrogen, and what we obtain afterwards is a carbanion. Now, moving on, if we move ahead to the hybridization of this CH3 negative, so this CH3 negative we have got here, and now I want to see the hybridization of this. So 3 bonds again, but with a negative sign too. So this is 3 sigma bond and 1 negative charge, label it as a lone pair. So this is actually an sp3 hybridized species. Now, since it is sp3 hybridized, we can call it non-planar, because sp3 species is lying on a single plane, so it is called non-planar. Now, moving on to the next point that I wanted to discuss with you. Now, this was the first point. Now, the second point is, if you see CH3 negative, which is the carbanion that we have been talking about, and what I do is, now I'm going to attach an electron releasing group to it. So what I'm going to do is, suppose this is CH3 negative, what I'm going to do is, I'm going to just attach an electron releasing group to it. Okay, so what happens is, this electron releasing group, of course, will give electrons to this. Okay, now let us just, we have to compare the two things that I want you to look about. So now what I do is, to compare it, we attach an electron withdrawing group to it. Now when I attach an electron withdrawing group, say it was CH3 negative, and now I'm attaching an electron withdrawing group. This electron withdrawing group, what it is going to do is it is going to attract the negative charge towards itself. Now, if I have to see the stability, we have always emphasized on how if there is charge and if there is negative charge, stability depends upon how and which group neutralizes the negative charge. So stability is dependent here on which group is able to neutralize this charge. Now, let us see the two groups. We have an electron releasing group and we have an electron withdrawing group. If it is a negative charge and I have an electron withdrawing group, it has more capacity to neutralize it because the electron releasing group will end up making it more negative. The carb anion that we are talking about, it will make it more negative, and what it does is this destabilizes the carb anion, whereas on other hand this stabilizes. And why does it stabilize? Because it is neutralizing the charge. How it is stabilizing? Because it is neutralizing the negative charge. Now, since it is neutralizing the negative charge, of course, it is providing stability. So, if I have to write a general statement on stability, I can write that electron withdrawing groups whichever groups are electron withdrawing groups stabilize the carbanion. So I have got a general statement here in front of me, and it says that electron withdrawing groups, whichever they are going to stabilize the carbanion. Okay, so you've got the basic gist of the topic. Now, coming forward, moving ahead, we have here an example and we have to tell the stability, that which one of them is the most stable and which one is the least. So we have just emphasized the point that any electron withdrawing group will lead to the stabilization of carbanion, and any electron releasing group will lead to the destabilization. So here you can see let us number them first to avoid any confusion. So this is the first one, second, the third, and the fourth. Now, in the first one, we don't have any electron releasing group, so we leave it at that. Moving on to the second one, we have here in front of us a CH3, which is actually an electron releasing group. The third one, we have two CH3 group, and in the fourth one, we have three CH3 groups. Now what CH3 does is, we have learned that CH3 is showing plus I effect, or it is releasing electrons. So CH3 group, what it does is it releases electrons. So it is releasing electrons towards our carbanion here, and here we have three of them. So this is the case. So we have one group here, one electron releasing group here, we have two electron releasing group here, and we have three electron releasing group in the fourth case. Now, since electron releasing group releases electron, and when it releases electron, destabilization of carbanion occurs. So now, when electron is getting released, what happens is destabilization is occurring. Now, what destabilization does is that since there are three groups here, 1, 2, and 3 group, this will have the maximum or cause the maximum destabilization. So, if I see this, then the maximum electron density which is accumulated will be at the fourth one. Okay, the fourth one has the maximum electron density on this carbanion. So we can say that the order of stability that we wanted, the order of stability, the lesser the electron releasing group, the more is the stability. So which one has the least electron releasing group? This one, the first one, has no electron releasing group. So it is going to have the maximum stability. So if I write the order, it is the first one is greater, then the second one is greater, then the third one is greater than the fourth one. This order is opposite to that of the electron density which is present. So if someone asks me the order of electron density, it is just the opposite of this. Why the fourth comes last, we'll just write here that it has maximum electron density. And when this has the maximum electron density, it is gonna cause maximum destabilization of the carbanion. So the order of stability is 1 greater than 2 greater than 3 greater than 4.